What's up, you guys? Are y'all ready for the finals round problems? Because I am a little bit. Actually, I'm more terrified. I am extremely terrified to what's about to come. Oh my god, I'm gonna stretch. Okay, I'm ready now. Alright, let's start some Caltech problems from its bracket rounds. Alright, let's go. Too easy. This is like too. No, I'm just kidding. I'm not gonna do it in my head. I actually don't. I don't memorize the answer for this. And you don't have to. You do not have to. But what you can do is remember the process of solving this. And let's see if that's what we have. That is exactly what we got. Okay. Awesome. Ooh. A good first start. This is just by looking at it. That's that u equal cosine, but I get a negative. Then sine, and then but then I also got sine here, which also cancels out the negative. So my answer should be cosine sine cosine. Yeah, I think it's just positive cosine sine cosine of x plus c. Yeah! Mental integration. Okay, this I can do mentally. I cannot do that mentally. Here, but we know already, like, what's the first thing that we do when we see this? What is the first thing we do? No, it's not inverse jailbreak. Okay, we don't have bounds. We do a forced U substitution, right? Honestly, I actually like the idea of doing this. If I want to obliterate my opponents, this is how I would go about it. And then 2 secant u square tangent u. Yeah. And so now this is just 2u secant square of u tangent u. Right? But you already know the integral of this, right? This is, you just derived it. Right? You already know the integral of this. So, because of that, you could just, you know, tangent, whatever. And this is already secant square of u. Whatever. I'm just being lazy, I'm sorry. But, this and that, tangent of u. Right? So, it's, you technically have the answer. So you don't have to work as hard as much. Or you don't have to think as much, or hesitate as much. So, we have u secant square of u minus tangent of u. And so now turning it all back, we have, let's see, remember secant square? So it's x inverse secant square root of x minus tangent of inverse secant. That's tangent of inverse secant is, I think that's this. Yeah. So then you pretty much have square root of square root of x minus 1. I think that's correct. I think that's correct. I think. Risk it. Yeah! Let's go! Woo! There you go. So, integration by parts. Alright, next one. Oh my god, no. No! Oh, god. Why? So, whenever you come across this, I think that this is a good time I kind of teach you how to do geometry. So, this is actually very hard to do. So, I'm not gonna use colors, because you're gonna need to learn how to do this, because you're not gonna be given multiple markers. Okay? I'm sorry, but this is where you're on the board, and this is how you kind of strategize. First of all, notice if you can, make it, let's say, like, if you have like something like symmetry, because there are sometimes where people would go like this, right? If you can, just go straight into symmetry. Okay. In this case, we're already given 0 to 1. So what that means is we only have to worry about the positive side. So the reason why that's important to consider is because we don't have to draw this graph. We don't have to draw this, you know, and like worry about what's on the other side. Now, here's the best. If you're like me who's bad at graphing, here's a way to do it. First off, graph 1 minus x. Okay, so negative x is this way, but we know that it's going to be 1. So here and 1. So when you're doing things like this, label your units. Okay, you'll thank me later. You will thank me later. All right. So from zero to 1, right? We might need this, obviously, but it's okay. That line is really bothering me. There we go. Okay. So, and then obviously it's going to go like this. Now, why am I doing it in a dotted line? Because now, after you graph 1 minus x, I want you to absolute it. Absolute it. Now, what's that going to look like? Now, it's going to reflect. It's going to reflect now. Okay? Alright, cool. So it reflects at 1. Okay. So we got that. Now what? Now I want you to do 1 minus this. Now, what does that mean? What does it mean to do 1 minus that function that we just draw? It means that we have to, first of all, let's take it easy. Let's start small. First, negative. Right? So a negative version means what? This. Right? This is negative 1. And then add 1. That means we have here at 1, right? But what's this? This is 2. Okay? This is 2. So, again, you see why I hate this, but this does happen. You will get into a situation like this. So, this is what we have. Right? And then what's next? Absolute value. Right? Because that's what we have. We have absolute value. Okay. So that means that this is going to be deflected like that. Okay? And this is going to reach to 1 at 3 here. Okay? So, but then, we have to do it again, right? We have to do it again, because we have this portion again. So we have to do negative, right? We have to reverse it. Okay. We're going to have to reverse it. That's a bad line. Okay, so negative 1. Okay, this is negative 1. This should be negative 1 here, but I just draw the line very badly. I'm so sorry. But, okay, negative 1. And then we translate it a unit up again. So we'll be having this. Boom. Boom. Boom, like that. Okay, and then what happened? Absolute value, which means that this here is gonna go like this. So from 0 to 1. Oh, you son of a! I didn't even have to do this. I just realized this is 0 to 1, bruh. Sometimes, okay, well, I mean, at least I get to show you what this is, because sometimes it's not like this. Sometimes they'll give you something like, usually they'll give you something like 0 to 3 of this function. And then you have to count out all the area. This is this function. Okay? So that's how you would go about things like this. And that's, now you know why I hate these absolute value functions. Because you actually have to graph it. Alright? Otherwise, you'll be stuck doing it equationally, and that's going to take forever. Here, in this case, we only have to worry about 0 to 1, which was a lot faster. So what I could have done instead is, instead of drawing this whole portion, you only have to focus on 0 to 1. Right, because the bound, I didn't realize the bound is only from 0 to 1. So you only have to focus this portion here. And obviously this is equal to a half. Right, so I don't know why I didn't figure that out, but that was literally equal to a half. So to recap, right, if it was because it was only from 0 to 1, you only had to focus on 1, 0, 1, a unit square pretty much. And then you just kind of be like, okay, this is negative x. It was negative x. And we translate it up, right? We translate it up, and then it goes here. And then we, it was absolute value. We go negative, right? And then plus 1, translate up. And then you notice that it's a pattern, it goes down, plus 1. And absolute value, and then it's easy to see that no matter what you do repeatedly, it's gonna periodically flip back and forth, and you're just gonna end up with this. Okay, so that's how I would actually go about that integral specifically. But usually the integral is usually from 0 to 3, but here I guess they just want to be gentle, 0 to 1 only. So the answer is 1/2. Okay. This x squared plus 1. You would go you don't be afraid of negatives. I think that's the thing. For beginners is, don't be afraid of negatives. It's something that you have to get used to. You just have to get used to it. Right. Next minus 1 plus 1, which also adds to the 1. Okay. Right. So you get 1 minus x, 1 minus x. So you get negative x, negative 1 plus 2 over 1 minus x. So, because of that, you just get this as your answer. Okay, where everything's negative. Supposedly. Yeah. Okay? So, for beginners, don't be afraid of negatives. Oh, what the hell is this? This is a reverse product rule. Ah, see, it's so important that you recognize what is reverse product rule, or recognize reverse product rule. So obviously this is 0 because we have ln of x. Ln of 1 is 0. So we only have to focus on ln of pi over 3 times secant of pi over 3. Secant of pi over 3 is 2. So I guess it's 2 ln of pi over 3. Yeah! Okay, so recognizing reverse product rules is very, very important. Oh my god. Negative. Wouldn't this be 7 factorial? 7 factorial? I think that's 7 factorial. But for those, this is a gamma function. You have to be very careful when you do this, right? You have this is an odd function, so the negative will go out. Thankfully here, it cancels out the negative, so you'll be left with this, which equals to 7 factorial. Okay? So be very careful. If this negative wasn't there, then this would have been negative 7 factorial, because this is an odd function. Oh, what the fuck? Oh my god, what is this? Let's play with it for a little bit. First of all, I noticed that I would separate, right? And this is equal to x plus square root of x minus 3 squared, right? And then on the bottom, we have square root of, so it's like, oh, it's nasty. 1 to the power of 6 of x, sorry, square root of x minus 3, 1/3. Excuse you, why are you doing this? Is this some sort of reverse product rule BS? What kind of crappy reverse product rule did you give us? What is this? This is so horrible. Oh no. Is it one of those semi-integration by parts? Is that what this is? I would guess 6.5. I would guess 6.5 x to the power 5 6 times this. This would be my guess, but I'm positive I could be wrong though, because I feel like either they messed up or I messed up and the answer is actually not reverse product rule, it's like some semi-integration by parts. Oh, I was right? I was right. Well, I got it right. Well, I mean, this didn't follow up, but okay. Well, there you go. You know, when in doubt, just guess. There you go. It's one of the strategies I learned from UC Berkeley. Oh, that's evil. Oh, actually, it's not as bad. So this is actually just, this is, they're all positive, right? Yeah, they're all positive. So you get x plus 1 cubed. So you get x plus 1 minus 1 over x plus 1 to the power 4. So that's what you get. Did I do that right? Yeah! Okay. Woo! E to the tan x. Oh, ln of secant e to the x plus c. Yeah, too easy. This is, I want to say, square root of 1 minus x squared. Huge shout outs to this well, I don't know if they're comfortable with me saying their name on this video, but this is pretty much square root 1 minus x squared, right? This is okay. If you have something like this, or, I'm sorry, if you have a trig, and then a trig inverse, okay? Or some sort, or whatever. But it's like a different trig, right? Then it's gonna equal all the time. You don't have to worry about the domain and range, okay? If you get this, then some different trig, then you have to be very careful about the domain, okay? So this is a different story, right? But because ours is in a different way, it's in this format, we don't have to worry about the domain. So, with that in mind, I can just simply answer square root of 1 minus x squared. Okay? I don't have to worry about the domain. If you want, the easiest way is to let x equal sine theta. Right? What's going to give you is cosine squared theta. D theta, and then if you're fast enough, you can just go ahead and simply answer like, oh, this is like theta over 2, sine 2 theta over 4. If you're fast enough and accurate, right? And then you have to do like a half of inverse sine x plus 1. You're pretty much racing your opponent on time. So you have to be very extremely careful. That might be wrong. I don't know if I did that correctly. But you have to race your opponent with that. Controlling the numerator is an important concept that beginners need to learn how to get comfortable with. So let's go ahead and learn how to control the, well, actually there's two things you can do. You can do heavy side, because I realized the bottom is factorable. So you can do heavy side, or you can control the numerator. Yeah, no, it's not going to work out, right? Pretty much you have the plus 2 here if you want to complete the square, but it's not going to be pretty. Why? Because you have this, and this is not, you know, this is nasty, right? So this is where I wouldn't control the du. I wouldn't control the numerator for obvious reasons, as you can see. But this is my last resort if this was not factorable. But because it's factorable, it would be better to do heavy side method, So, Heaviside method, we just go from x plus 1, x plus 2, go negative 1, it's 1, negative 1, plug in negative 1 here, it's negative 1, plug in negative 2, that's negative 1, plug in negative 2 here, we get negative 6 plus 2, negative 4. Alright, so it seems that we have x plus 2 here minus ln of x plus 1 here. And that would be our answer. I believe that's what we got. Yep, there you go. Here, this is a very common integral. You should already know how to do this. So you should get ln of e to the x minus 1 minus x plus c. Or write it like, God, overcomplicate it, I guess. I don't know why they do it that way. Ooh! Another integral that you should know how to do. Intermediates. Intermediate people. You should know how to do this. This is a very, very common integral. Yeah, this is literally x to the power of 2025 over 2. I know it's very hard to see, but just trust me on this. So if you put that at the bottom, but we have an x here, so we just get 2025 back, which is u. And now this is easy to see that this is inverse secant. Okay, they probably have a different answer. I bet you they probably have like 2 arctan something. Yeah. You don't have to do that. You do not have to do that. Okay, that comes from force subbing, letting u equal this whole thing, and then you get u squared plus 1 of x to the power of 2025, right? Then here, this is x to the power of 2024. So you multiply x to the power of 2024 top and bottom, and you get what? This. This is where it comes from. And so with this u substitution, and that's how this answer comes from. You get this, and you get inverse tangent of this. Okay. However, I don't know. I like to do the inverse secant. It's just a lot faster for me. Where's the integrand? Okay. Well, this is actually a lot better than this. This is better than this. And let me tell you, well, I mean, you should know exactly why, right? This is reverse product rule. You can easily integrate that. This part, you're kind of stuck to just memorize this. Because you're just integrating this now. Yeah, I just write it. Just write it all out. Just write it all out. There's no need to simplify. Huh. I wonder what this is. Y'all should know this. This is a sum of inverse. So this should be like 0. Yeah. It's a very common textbook problem. This is the sum of inverse functions. Right? Just talking about this. Just this portion. If we only focus on this portion here, right? This is, we take the inverse, we get x equal, we get b root of 1 minus y to the power of a. What is, if I plug in 1, you get 0. If I plug in 0, you get 1. And that's where this comes from, right? That's why this is simply equal to what? 1 times 0 minus 0 times 1. That's why this whole thing is equal to 0. And that's why this is flipped. That's why this has a negative. Okay? So it's a very common integral. Very common integral. Even it appears in textbooks as well. Caveman trick. And I swear to God if they have something else. Yeah, I knew it. I knew this was gonna happen. But this is the same thing. It's the same answer as this. They just don't like negative exponents. That's it. Oh God, no. No! It's this G tradition. The freaking, oh my God. The JEE exam does this way too many times. Oh my God. I genuinely don't want to do this, but let's say if you were to compete. This is to all you Indian bros out there. If you were to compete and you're stuck with this integral, God, I'm sorry, but I can sort of show you. Oh, that's a cube at the bottom. Ugh. Okay. Well, so first of all, this bothers me, right? So let's actually simplify this by going like, plus 1 minus 1. So what that means is we have x plus 1 square. So x plus 1 minus 1. So we have minus 2 x plus 1 cubed. And we want to know f and f prime. Oh, would you look at that? Would you look at that? What is f and what is f prime? Ah, this is f of x. So our answer is e to the x plus 1, sorry, e to the x over x plus 1 square plus c. Yeah! Oh my god. So that's one way. So be careful. Sometimes you have to go through this route, right? Just take small steps and then you realize, oh, and then you just, reverse product rule. Okay. This looks familiar. I think is this from MIT? That looks like an MIT qualifier problem. Ah, ha. And now this is equal to a half of sine 4x dx, and now this is just negative 1/8 of cosine 4x plus c. So negative 1/8 cosine 4x. Yep. There we go. Oh god. Oh no. This is one of my terrifying nightmares. Cosine square, sine cube. Okay. There's two ways to go about this: the textbook way and the G way. The G way is to let 1 on top. The numerator is equal to 1, and let 1 equal sine square plus cosine square. The reason why I'm not a fan of this is because of this. Okay, and this. This will give you cosecant cube, and you don't want to deal with that. This is god awful. Who in the forsaken mind would do this? Tangent. Oh, wait, what am I doing? Oh, I'm sorry. I missaw this. Yeah, I don't know if you want to do this. I don't know. And then this is tangent of x. Ooh! Okay, so thank God for testing. Tangent of x cosecant cube, and then plus, and then this is minus 3 cotangent of x plus c. Or whatever the hell that is. Oh, it's one of these. Oh, god damn it. This is a very common integral, but it still annoys me till this day because of how bashy it is. And I bet you $5 Caltech probably simplified this. This is like ln of 1 plus cosine of x. Oh, that's crazy. Is it really this? I don't know about this. That's a little sketchy. That should be x over 2. I don't know. It's a little sketchy. That's a little sketchy. That might be incorrect, but I could be wrong. Oh, come on. Don't do this. Don't do this. You guys, if you're an integration problem writer, do not shove a textbook problem to students. Okay, you gotta do it with style. Come on, a computer algebra system style integral. Okay, so like I said, right? This well, actually no, I'm sorry. No, I'm thinking about something else. But this is equal to inverse sine of. Oh, I'm sorry. I need to do the root 5. Check. Root 5. Root 5. Root 8. Oh no, I'm sorry. Root 5 here. That still looks like 8. I am so sorry. This is a mess. I think this is my answer. I'm too lazy. This is so unmotivating. I don't want to do this. Okay, thank God. Yeah, it's not root 5. So this is what you get. Yeah, this is exactly what I have. It's exactly what I got. Okay, so I got that answer correctly. Thank goodness. Not a motivating problem. Oh my G main. Multiply top and bottom by let's see. Does that work? I guess you could do integration by parts like this, because now it's a lot more simple, right? Because you definitely know how to do derivative of this. It's simple. Okay, I guess. Oh, wait a minute. Tangent. This combines with this. Oh, that's exactly what we have on top. Oh shit. So this is equal to 2. So then that means that this is x inverse tangent secant x minus tangent of x minus, yeah, this is my, don't forget that. And so this x squared plus c. Oh shiz. That's crazy. I would not expect that. I could be wrong. I wouldn't be surprised if I'm wrong though. What the fuck? Huh? I'm sorry. What? I don't. Huh? My brain? My brain. My brain. Ouch. My brain hurts. Oh, negative half. Oh my fucking god! God damn it. It's freaking. It's a negative 1/2. Well, oh my god. Ah! But god damn it. I swear to god. Oh my, come on. Come on. Oh god. Why? Why are you doing this to me? So... Oh my goodness, I don't even want to. So this would be like my answer. I'm done. Why is this e4 minus 1? I refuse to believe this is e to the power of 4 minus 1. There's no way in hell. Oh, by getting negative x, that's what I messed up on. Oh my god! Ugh! Ah! Okay. So, Yo, why? Why would you do something like this? Why would you give your children this? This is... Oh my god. Okay. Alright, Caltech, I'll play it your goddamn way. Jesus. Negative... I don't want... No. I can't. This is too nasty. No one likes this. Who would like this? If you like graphing, you need to socialize. Because I can't stand you people with graphing. Okay. This is root pi over 2. Root pi over 2. Yeah. Ninja sub. Okay. That is interesting. So, oh, you know what I noticed? Oh, I hope all of you caught this. I genuinely hope all of you caught this. So we have cosine and sine here, right? We have 2025. Now look at this. I'm going to say plus. This is x of pi over 2 minus x. Do you see what I'm seeing? This is equal to the same thing as this denominator, except that now we have sine and cosine. We get 0. I believe that's what this integral is. 0. Yeah. Okay. Very nice eye catch. Oh. Norwegians has started this tradition. if you have a function where it's periodic at some, for some t, t times some value, right? And this function is periodic at t, then this is equal to, alpha times 0 to t f of x dx, right? If you remember the periodic property, like we always do this for this, right? Like this is a good example, right? This is a times 0 to 1, right? Because it's periodic at 1. This is going to be, what, 10, 13? From 0 to 2 pi of 1 plus e to the sine x. We can do Queen's rule. So, which we just apply. See, if we do Queen's rule, right, let u equal pi minus x. This is exactly what I want. Negative pi to pi. Okay, because look, what can you do? Ninja sub, right? Let u equal negative x. Oh wow, so is this everything 26 pi? Is that the answer? 10, 13. Oh, god damn it, I keep forgetting. When you do ninja substitution, for the love of God, divide by 2. Don't be like me. God damn it. Yes, it's 10, 13 pi. I keep forgetting, when you do ninja substitution, divide, oh god, just divide by 2. Okay? Because you're solving for 2i, you're solving for I, not 2i. Okay? So, no, it should be 10, 13 pi. What on earth? Oh, hold on a second. Now I want to try what this is. That's crazy. That's crazy. That's wild. That I cannot believe that. That's oh shit. Woo! Experiment with your derivatives. Okay. This is now plus 1, 8/5, 5/8. So now this is 5/8 of u, sine of x, 1 plus cosine of x. Oh my god. I cannot believe I solved this. I cannot believe. That's crazy. Oh yeah. Tangent x over 2. Yeah, that also works. For those who are curious why this is equal to tangent of x over 2, it's because it's this. If you treat it like double angle, right, you get, this is also 2 cosine square. This cancels out, and this cancels out, and you get tangent x over 2. Okay? This is an odd function, so that's equal to 0. So we get x squared cosine x. Alright, no problem. Oh, but this is also 0. Oh, wow. Okay, awesome. So it seems like our answer is pi squared over 2 minus 4. Yeah, perfect. That is terrifying. I don't know how to react to this. Something like that. I don't know. I'm too lazy. Oh, there was bounds? What? There was bounds? Were there bounds? I don't remember recalling bounds. I'm assuming it was from 0 to pi over 2.